friends and hello sir. Let me briefly introduce myself. My name is Sasintin Analiki Karnanidhi. My metric card number is 04 DPT 19F1044. I am from class DPT 3A. I am studying at Politeknik Kota Bahru Kelantan. I am delighted to be here today to talk to you about my experiment 1. My experiment 1 title is Determine the force in equilibrium system. Objective of the experiment is number 1 is to measure the force in strings. Number 2 is to find the resultant force in the system. Number 3 is to investigate equilibrium force for a particle at rest. The equipment for this experiment is number one is lithoid stand. Number 2 is neutral spring balance. Number 3 is set of slot with hanger. Number 4 is strings. Number 5 is protractor. Number 6 is ruler.
Now sir, we go to the first experiment. Determine the force in equilibrium system. I'm going to tell the procedure how to do this experiment 1. First step is set the apparatus as in figure 1. Second step is squat 150 gram at the squat. Third step is put a string horizontally at the intersection as a datum. Fourth step is record the forces into the table. And fifth step is record the angle into the table. And the last step is repeat the step 2 to 5 with 250 gram and 350 gram. You have to repeat the step 2. The step 2 is squat 150 gram at the squat, but we have to repeat with that step in two different weight, 250 gram and 350 gram.
Hi sir, my name is Srinivasan Pakinathan. My metric number is 04 DPT 19F1014. Now I want to explain calculation for experiment 1. This is our data result for experiment 1. First of all, we get 3 results for this experiment. First result, mass for first result 0.25, force A are 1.5, force B are 1.7, force A angle are 60%, force B are 120, and calculation for result 1 2.45, and force resistance for result 1 0.31. Then we get second result is mass for second result 0.50, and force A are 2.6, and force B 2.9, force A angle are 71, force B angle are 150, and calculation for force calculation for result to 4.91, and force resistance are 0.90. Then mass for calculation 3 are 0.75, and force A are 4.0, and force B are 4.1. Angle are 70, angle for force B 160, and calculation for result 3 are 7.36, and force resistance are 0.10. Final answer is 5.10 equal 4.91 equal 0.90 is final answer. And then last mass is 750, force A 40, x component for force A 40 cos 70 equal 1.37, y component for force A 40 sin 70 equal 3.76, force B 4.1 cos 160 equal negative 1.79, y component 4.1 sin 160 equal 3.69, total force resistance x equal negative 0.42, force resistance y is 7.45. The calculation for this all and last answer is equal 0.10. And that's all for experiment 1. Thank you. 70 equal 1.37, y component for force A 40 sin 70 equal 3.76, force B 4.1 cos 160 equal negative 1.79, y component 4.1 sin 160 equal 3.69, total force resistance x equal negative 0.42, force resistance y is 7.45. The calculation for this all and last answer is equal 0.10. And that's all for experiment 1. Thank you.
Discussion and conclusion from this experiment 1. We learn how to set a system of different weights into equilibrium by changing the angles and the weights in each string experimentally and by equation of equilibrium theoretically and by drawing a force polygon graphically. From the analysis, we noticed that the percent of error was high, about 46.2% in magnitude and 31.78% in direction. That is because of the sources of errors we are in this experiment. The sources are mentioned in the next headline. Now I am going to discuss some of them. One of the reasons is high error was that the pulleys do have a friction, but in our calculation we didn't consider this friction. The tensile force each string exerts on the ring should be equal to the weight and the friction from the pulley. Another source of error was that we have seen all of phases to be coplanar forces at the same plane, but this wasn't satisfied 100%. That means that there are zero components for the forces. We didn't consider a third equation in our calculation. The ring was certainly at rest. It really was at equilibrium. The question is, what the sum of forces equal to 0? There are two issues here. One is whether or not we included every force in our calculation. The other is, even we did include all the forces, what does equal to 0 mean in this context? That sounds like a silly question, but it really is at the here of laboratory work. There is a limit as to how precise a laboratory measurement you can make. This means that there is a limit how to precise your calculation can be. The specification say that if the percent of error was higher than 15%, then the device is defected. How true is this?